Hello students, in today's lesson the concept of polygons, nomenclature of polygons is introduced. Then the angle sum property is deduced for all polygons from the angle sum property in triangles. Dear students, let us explore some plane curves. Can you recall what is a plane curve? Yes, a plane curve is a figure obtained by joining points on a plane, maybe on a paper without lifting pencil. Let us see some plane curves. Yes, here are some 6 plane curves. We see that some of these are made up of line segments. Some are not. Some of these are simple, but some are not. Some of them are closed, but some are not. A simple closed curve made up of only line segments is called a polygon. Let us identify some polygons. Here you are seeing 3 polygons, which are simple, closed and made up of only line segments. Can you make some observation about the number of sides and number of vertices in a polygon? Yes, in any polygon the number of sides is equal to the number of vertices. A polygon with n vertices, that is with n sides, is also referred to as a n-gon. Let's see what do we call polygons with 3, 4, 5, 6, 7, 8, 9 and with 10 sides. A 3-sided polygon is called, yes, you are right, a 3-sided polygon is called a triangle. A 4-sided polygon is called a quadrilateral. A 5-sided polygon is called a pentagon. A 6-sided polygon is called a hexagon. A 7-sided polygon is called a heptagon. A 8-sided polygon is called a octagon. A 9-sided polygon is called a nonagon. A 10-sided polygon is called a decagon. These are the names given to polygons with at most 10 sides. In polygons having 4 or more than 4 vertices, we see that we can draw line segments to join 2 non-consecutive vertices. For instance, consider this quadrilateral PQRS. Here, line segments SQ and PR. Consider a pentagon ABCDE. Here, the line segments AD, AC, BE, BD and CE. And consider this quadrilateral KLMN. Here the line segments KM and LN. What do we call such line segments as? A line segment joining 2 non-consecutive vertices of a polygon is called a diagonal. Now based on these diagonals, let us try to see different polygons. Now consider the quadrilaterals PQRS and KLMN. Do you find any difference between the quadrilaterals PQRS and KLMN? Yes, based on the diagonals. Right, exactly. Both the diagonals of quadrilateral PQRS lie in the interior of it, while the diagonal LN of the quadrilateral KLMN lies in the exterior of it. A polygon for which all its diagonals lie in its interior is called a convex polygon. Otherwise, the polygon is called a concave polygon. Now let us consider the 2 polygons shown on the screen. Here both are quadrilaterals, but there is an important difference between them. Can you identify it? The second polygon has all sides equal and all interior angles equal, while the first one do not have this. So we have the following two definitions. A polygon whose all sides and all angles are equal is called a regular polygon. A polygon which is not regular is called irregular polygon. Let us take an example for a regular polygon. An equilateral triangle is a regular trigon. Can you tell why? Yes. An equilateral triangle is a three-sided polygon in which all three sides are equal and all three angles are equal to 60 degrees. Therefore, an equilateral triangle is a regular trigon. Similarly, a square is a regular fourgon. A square is a four-sided polygon whose all sides are equal and all interior angles are equal to 90 degrees. Therefore, a square is a regular fourgon. Now, let me give you an exercise for you to think by yourself. Is rhombus a regular polygon? Answer it by yourself. Now, we move to the interesting part of our lesson, that is the angle sum property in convex polygons. Let us do an activity. Take four identical, that is four congruent copies of a convex quadrilateral of your choice. Name it as ABCD with interior angles marked as 1, 2, 3, 4 as shown on the screen. We have considered a quadrilateral ABCD and we have marked the interior angles 1, 2, 3 and 4. Similarly, you can make 4 copies of a quadrilateral of your choice. Now, in step 2, arrange these 4 quadrilaterals vertex to vertex as shown in the figure. Join it to form the sum of the angles 1, 2, 3 and 4 around a common vertex. What do you observe? Write down your observation about the sum of angles of a quadrilateral. We observe that the angle sum of the interior angles of a quadrilateral is 360 degree. Yes, we observe that the angle sum of the interior angles of a quadrilateral is 360 degree. This observation we could make because the angle around a point is 360 degree. Okay. After determining the angle sum property in a quadrilateral, now let us determine the angle sum in a pentagon, that is in a figon. But to repeat the same method, we observe that it is time consuming and as well as tedious as the number of sides become more. So let us see a simple method of determining the angle sum in any convex polygon. Let us start with the quadrilaterals. Let us consider a quadrilateral ABCD as shown on the screen. Now join A and C to form the diagonal AC. Now mark the angles 1, 2, 3, 4, 5 and 6 as shown on the screen. Now can you identify the triangles formed in the figure? Yes, we have two triangles. They are triangle ABC and triangle ADC. Also, we observe that the angles 1, 2 and 3 form the interior angles of triangle ADC and angles 4, 5 and 6 form the interior angles of the triangle ABC. By using the angle sum property in triangles, can you determine the sum of angles 1, 2, 3, 4, 5 and 6? Yes, the sum is 180 degree plus 180 degree, that is 360 degree. But this sum is nothing but the sum of 4 interior angles of the quadrilateral ABCD. Therefore, we conclude that the angle sum of the interior angles of a quadrilateral is 360 degree. Now, let us use the same method to determine the angle sum in a pentagon. Draw a pentagon ABCDE as shown in the figure. Next, join vertex A to vertex C and vertex D to form two diagonals AC and AD. Now mark angles 1, 2, 3, 4, 5, 6, 7, 8 and 9 as shown in the figure. Now observe that there are three triangles and the sum of all the angles is the angle sum of the pentagon. Now by using angle sum property of triangles in triangle ABC, in triangle ADC and in triangle AED, we observe that the sum of angles is equal to 3 into 180, that is equal to 540 degree. Therefore, the angle sum of the interior angles in a pentagon is equal to 540 degree. Doing similar exercise for a hexagon, that is a six-sided polygon, we see that the angle sum in a hexagon is 4 into 180 degree, which is equal to 720 degree. Can you make it out from the figure? Yes. So we have the following pattern for the angle sum of convex n-gons. For a three-sided polygon, we have the angle sum is equal to 180 degree, which is equal to 3 minus 2 into 180 degree. For a four-sided polygon, we have angle sum equal to 360 degree, which is equal to 4 minus 2 into 180 degree. For a five-sided polygon, we have the angle sum is equal to 540 degree, which is equal to 5 minus 2 into 180 degree. For a polygon of 6 sides, the angle sum is equal to 720 degree, which is equal to 6 minus 2 into 180 degree. Therefore, for a polygon with n sides, we generalize the pattern that the angle sum in a convex n-gon is n minus 2 into 180 degree. So we now know the angle sum property of polygons. Let us end this session by recollecting what all we learnt today. First, we learnt what is a polygon. Then we defined a diagonal of a polygon. Then we distinguished polygons into convex and concave polygons. Finally, we learned how to deduce angle sum property of n-gon using angle sum property of triangles. Hope you had good time watching this video. Thank you.